All right, and so we do have, in this case, we are looking at variables on both sides. And so again, just a little bit more work to do here than what we have done in the past. Nothing too crazy. We've got 17v minus 4v plus 27 is equal to 4v minus 18. And so again, we want to clean up each side of this equation as much as possible before we proceed. Cleanup to me means doing things like combining like terms or the distributive property. So 17v minus 4v is going to give us 13v plus 27 is equal to 4v minus 18. And now what we've got is we have a condition where we have a choice to make. I could choose to subtract 27, or I could choose to add 18. Either one of those will produce a correct answer at the end of this, and it doesn't matter which one you choose to do. I'm personally going to make the choice most of the time that is going to make the number positive, because I like dealing with positive numbers more than I like dealing with negative numbers. And so I'm going to choose to add 18 to both sides. That's going to give me 13v plus 45 is equal to 4v. Okay, now I have variables on both sides, and so I do need to move that. I do need to isolate the variable, which means to get the variable on one side. And so what I often see students do is they subtract 4v, and then magically they decide to move the equal sign and say, okay, now this is 9v is equal to 45. Well, we can't do that. What this person, if they're doing this, just did is completely nothing related to solving equations. Now they're inventing rules that I can move the 45 to the right side with no consequence. What would end up happening is we would end up with, instead of this, what you would actually have would be 9v plus 45 equals 0, which is okay. But it's important to understand that we can't just start making up things at this point. And so actually doing that, subtracting the 4v, is probably a bad idea because it doesn't help us get the variable on one side. What we do need to do, though, is recognize that we want variables on one side and numbers on the other side. So I'm going to subtract 13v, which is going to give us 45 is equal to negative 9v. And so finishing off this darn thing, we see that we're multiplying v by negative 9. We need to divide v by negative 9. 45 divided by negative 9 gives me negative 5. So again, please don't start inventing rules and this kind of stuff. If you're going to subtract, in the case of right here, if you did subtract that 4v, recognize that you would be left with 0 on that side. It would not turn into something that would say 9v equals 45. Never going to work. So keep your line down the middle, keep things organized, and remember our goal is to get variables on one side, numbers on the other side. All right, moving on to the next. We have 5y plus 6 is equal to 9y plus 30. Now again, I have options here. I'm going to choose what's going to work best for me. I could choose to subtract 5y. I could choose to subtract 6. I could choose to subtract 9y. I could choose to subtract 30. Any of those options are okay because anything that we do to an equation, as long as we do it to both sides, is totally fine. Again, I like it to be the situation that I'm dealing with positive numbers whenever possible and not negative numbers. So I'm not going to choose to subtract 30. I'm going to choose to subtract 6. If you chose to do any one of those 4 things that I mentioned, you will still come out with the correct answer. It doesn't matter. Just choose something to do and do it. So we got 5y. 6 minus 6 makes 0. That leaves 9y plus 24. Now again, here's what you cannot do. You cannot say, oh, I'm going to subtract 5y And then I'm going to end up with 4y equals 24. That is not at all, that doesn't make sense. How did the 4y and the 24 get to opposite sides of the equal sign? Please don't do that. If you did subtract 5y, you would end up with 0 equals 4y plus 24. And that would be okay. You would have to take care of it from there. But again, probably not the best approach. The best approach is going to be to get numbers on one side and variables on the other side. We already have 5y on the left, so let's move 9y over by subtracting 9y. We end up with negative 4y is equal to 24. See that y is being multiplied by negative 4. We need to divide by negative 4. We get y equals negative 6. Okay. Next, we have 2v plus 9 is equal to 8v plus 21. There are at least 4 correct things that you could choose to do here. You could subtract 2v, you could subtract 9, you could subtract 8v, you could subtract 21. All of those would produce a correct answer. For me, again, I like to keep my numbers positive, so I'm going to subtract 9 from both sides. I get 2v is equal to 8v plus 12. And again, I can't start making up math here, okay? It's a terrible idea, probably for most people, to subtract 2v. We already have v's on the left. Let's just move all the variables to the left. So negative 8v, or subtract 8v, subtract 8v. On the left, we would get negative 6v. On the right, 8v minus 8v makes 0. Leaves us with 12. We see we're multiplying v by negative 6. We need to divide by negative 6. And we get v is equal to negative 2. Okay, one more. We have 5x plus 16 is equal to 3x plus 6x minus 12. I want to do some cleanup work here because I do see that I can combine like terms on the right. So I'll have 5x plus 16 is equal to 9x minus 12. And again, I could do anything here. I could subtract 5x, I could subtract 16, I could subtract 9x, I could add 12. All of those would be an appropriate thing to do. I'm going to choose to add 12 because it will keep my numbers positive. So I've got 5x plus 28 is equal to 9x. And now I'm going to choose to subtract 5x from both sides. And I get 28 equals 4x. We see that x is being multiplied by 4. We need to divide both sides by 4. We get 7 equals x. Okay.